Closed system, only energy exchange occurs but not matter. Here list of properties given, those are intensive and extensive properties, these you have to remember. So how to check here? First you take AB here, it is slow process, it is fast process. Remember here, work done on the system, it is work done is positive, work done by the system we take work done is negative. See some fundamental questions here. One small mistake in understanding system and surroundings can lead to wrong concepts throughout thermodynamics. Let's fix that in just few minutes. Hello students, let us start. Important terms of thermodynamics. Basic terms are most important to solve upcoming questions. What is thermodynamics, especially chemical thermodynamics? It deals with the study of energy changes taking place in the chemical process. Important terms: system, part of the universe which is under observation, referred as system. Surrounding, the rest of universe excluding system is surrounding. Boundary, anything which separates system and surrounding is called boundary. Here for example, if I take beaker, what we show here, it is beaker wall, it is boundary. The content inside the beaker is a system. Around the beaker, whatever I showed around the beaker, entire part, it comes under surrounding. So inside the beaker, content is system. Beaker wall, it is boundary which is separating system and surrounding. Around the beaker, whatever other than beaker, outside is surrounding. So remember, boundary may be real, imaginary, rigid, non-rigid, conducting or non-conducting. It may be of any type. Types of system here. Open system, both energy and matter exchange between system and surrounding in open systems. For example, coffee in open cup. If you keep coffee in open cup, coffee vapors goes out as well as heat energy exchange with the surrounding. That's what we mentioned, energy as well as mass exchange with the surrounding here. Closed system, only energy exchange occurs but not matter. Coffee in closed cup. Like for example, if it is closed cup, only energy exchange occurs, no mass or no matter is exchanged with surrounding. Isolated system, neither energy nor matter is exchanged. So coffee in thermos flask, like here no energy, no mass exchanged. Thermos flask here meaning you can say no system is perfectly isolated. Up to few hours we can observe it, but later slowly it comes to normal temperature. State function as well as path function depends on initial and final state of the system, depends on path, work and heat. Like enthalpy, entropy. Here it is internal energy, enthalpy, entropy, Gibbs energy, temperature, pressure, volume, etc. comes under state function. Work and heat comes under path function. We are going to discuss each and every term in detail in this chapter. Just I gave here examples. Intensive as well as extensive properties. Mass and size independent, it depends on size and mass. Here list of properties given, those are intensive and extensive properties, these you have to remember. Molar volume, density, Gibbs energy per mole, specific heat, pressure, temperature, all concentration terms, boiling point, freezing point, cell potential, specific conductance, refractive index, surface tension, vapor pressure, viscosity. Here you can mention it as viscosity. Along with that, pH, dielectric constant, specific gravity. All these coming under intensive properties. Whereas extensive properties, volume, number of moles, mass, Gibbs energy, entropy, enthalpy, internal energy, heat capacity, force, surface area, kinetic energy. All these coming under extensive properties. And remember, ratio of two extensive properties is equal to intensive property. Like mass by volume is equal to density. Mass by volume, two extensive properties, density is intensive property. Intensive properties are non-additive, extensive properties are additive in nature, meaning two intensive properties, density. Densities you cannot add. Resultant d1 plus d2 is not equal to d total density. It is not equal. m1 plus m2, mass it is intensive property. Mass it is extensive property. But extensive properties you can add, m1 plus m2 gives total mass. So observe it under the note and close the note. See next. Types of thermodynamic process. Isothermal process, where isothermal process temperature constant here. Keep in mind that temperature is constant. So if temperature is constant here, delta T should be 0. Delta T is 0. P inversely proportional to V at constant temperature, Boyle's law. So P1 V1 is equal to P2 V2, or PV is constant for isothermal process. So here you can see V, P. Volume versus pressure graph. So that is expansion graph if you see here. Volume increasing, pressure decreasing at constant temperature. Isobaric process, pressure is constant here. which is constant, here pressure is constant. So if pressure is constant, final volume as well as initial volume if you observe, final volume, initial volume if you observe it, here overall delta final pressure, initial pressure, delta P is 0. So at constant pressure, volume directly proportional temperature at constant pressure. So V1 by T1 is equal to V2 by T2. Isobaric process, V1 by T1 is equal to V2 by T2. Next, after this, see the graph here, volume as well as temperature relation. Volume temperature relation, volume increases, temperature increases. Okay. Then isochoric process where volume is constant. Here volume is constant. So if volume is constant, then what you will get here? Delta V should be equal to 0. So here delta V should be equal to 0, P directly proportional to T here in this case. So isochoric process volume is constant, so delta V is equal to 0. At constant volume, P directly proportional temperature. We studied in gas laws. So P1 by T1 is equal to P2 by T2. So graph between P and T directly proportional. Adiabatic process, Q is equal to 0, no heat exchange. Further, we are going to see adiabatic process in detail after completion of few more topics. Cyclic process, process in which initial and final states are same. In cyclic process, change in all state functions will be 0, that is delta E is equal to 0, delta H is equal to 0, etc. All state functions is equal to 0 because initial and final states are same in cyclic process. For example, see here one question. Here the cyclic process given A, B, C, D with respect to arrow marks between pressure and temperature. Out of these A and B, which process correctly representing given question? This one question here. So how to check here? First you take AB here, BA, which is constant, pressure is constant in AB in question. So if pressure constant, we know volume directly proportional to temperature. Whenever pressure constant, under constant parameter pressure, volume directly proportional to temperature. In option A, you see here volume is, see here, pressure increasing, temperature increasing. Okay. If temperature, pressure constant here, so if temperature increases, volume also increases. Let us see now. In graph AB, what we can observe here? Graph AB, volume constant here. Volume constant, so temperature increases, pressure increases. So it's not isobaric, pressure is not constant here, but you observe it here. Here AB, so between volume and temperature, volume directly proportional temperature here. Volume directly proportional temperature. When volume directly proportional temperature, when it is pressure is constant. So here also temperature increasing, here volume should increase. Okay, because volume directly proportional temperature under constant pressure. So according to given question, but just if you see one process here, AB is temperature increasing at constant pressure, but you see here volume is constant, temperature increasing. So we need to find such process where process is isobaric and volume temperature relation, you can observe it. Process is isobaric, volume directly proportional temperature here. So it means it is isobaric. Option B is correct answer here. So you can say directly option B is correct answer in this case. Okay. Next, after that, reversible irreversible process. Reversible irreversible process. Reversible process, irreversible process. See, reversible process, irreversible process. For example, you see here, we are taking one container where gas enclosed into the container, their weightless frictionless piston is fitted to it. Outside there is external pressure acting on piston. From inside, P internal, that is gas pressure acting against it. Think that sand particles were adding particle by particle onto piston. So whenever we add sand particle, piston comes slowly down. You cannot notice even, but in infinite number of smaller steps. Sand particle adding one by one. So here piston slowly comes down. You cannot notice the change in position of piston, but it slowly comes down. It takes infinite time to complete. It occurs in infinite number of smaller steps. But here you observe it. One heavy object if you place at a time on the piston, suddenly compression occurs. Comes to directly here, piston comes suddenly down. So main difference here, it occurs in number of steps, here in single step. See, now we are comparing with that. The P external pressure is equal to P internal plus or minus dP. dP is very small pressure difference. So internal pressure is, that is gas pressure, plus or minus dP. So So plus or minus dp, or if you bring this side, P internal minus P external. For example, if you take like P external minus P internal is equal to very small. dp is small change in pressure, small pressure. So here it is negligible. Driving force is change in pressure, dp small pressure, which is almost equal to 0. If it is almost equal to 0, P external almost equal to P internal. Simply can remember, in the given reversible process, P external almost equal to P internal. P internal meaning that is gas pressure, almost properly balanced. Slightly P external dominates, but it is negligible. So that's why we consider here P external almost equal to P internal. Okay. Next, but irreversible process, P external is equal to P internal plus or minus delta P. It's not any small change in pressure, where delta P is not negligible here, delta P is not equal to 0. So in irreversible process, external pressure not equal to P internal. External pressure not equal to P internal. P external is dominating internal pressure. But in reversible process, P external process almost equal to P internal. Just step by step, we are going down. But irreversible process, P external is more dominant. P external not constant, but here occurs at constant external pressure. This process, throughout the process, external pressure is constant. Here, external pressure is not constant, it is changing. Step by step, we are adding sand particles. So, external pressure changes here. Okay. Example you see, P versus V, P versus V. So, here what we observe, the pressure slowly increasing, volume of overall gas decreasing. Here pressure is constant, throughout the process pressure is constant, volume that is increasing, volume changes. So pressure is constant during the process, whether it is expansion or contraction, whatever irreversible process, pressure is constant. Okay. Now P external not constant in case of reversible process, P external constant in case of irreversible process. Remember, process in which all changes occurring at any part of the system are reversed when small changes in variables are carried out in opposite direction. At any point of time, we can reverse the process by doing small changes in variables. But here it is not possible. It cannot be reversed by small changes in variables. See here. For example, if I remove sand particles here one by one, slowly piston goes up, slowly. So you can make it, these by making small changes here, you can reverse the process. But in order to reverse the process, small changes not sufficient. In order to reverse the process, you have to remove the heavy object. So by changing variables, you cannot reverse the process. That's what we mentioned here. Cannot be reversed by small changes in variables, but here you can do. P external minus P gas is very small here, but P external minus P gas is large. Occurs in infinite steps, occurs in single step. System is in equilibrium at all stages. Only at initial and final stages it is in equilibrium. Equilibrium meaning here, equilibrium meaning the piston should stay constant for some time. It is maintaining stable position here. So system can maintain its stability instead of moving above and below. It can maintain its position for some time, equilibrium. But here only at initial stage as well as final stage, piston remains constant for some time. And then it is slow process, it is fast process. Slow process and fast process. Okay. And later we are going to see reversible, irreversible and a different process. In detail we are going to discuss. Okay. Next, work and heat. Here work, force into displacement we know. For example, previously think that piston is here, think that piston is here. After exerting some external pressure, piston came here now, think that. So initial, if we consider it as expansion, what we do here? Initially here, but now finally piston is here, expansion. So initial volume is V1, final volume from here to here piston moved. So final volume is V2. Area of cross section of cylinder A. Then displacement, initial piston position to final piston position displacement is L. Okay, V2 is final volume. So now think that it is expansion occurring. So now during expansion V1 is less than V2, that we know. So force into displacement L is work. So force is pressure into area. So here if we consider area into displacement is delta V. We can write it as delta V, area into displacement. So delta V is V2 minus V1, but in sign convention, I can't IUPAC sign convention in chemistry, we write W is equal to minus P delta V by general. So general process, here we give directly sign W is equal to minus P delta V. This sign you have to remember. Minus P delta V, you have to remember here along with the sign. That is sign convention we use in chemistry. Physics we use only P delta V. So now IUPAC sign convention, see here. Case 1, whenever there is expansion of gas and compression of the gas. Whenever there is expansion of gas, V2 greater than V1, because expansion volume increases. Delta V is positive. What is delta V? V2 minus V1. Then W is minus P delta V, you will get. Delta V is positive, meaning if you input into this formula, delta V is positive, so minus delta, negative value. So whenever work done by the system, we use W is negative. Work done by the system, why are you using here? Because expansion it is. Expansion meaning gas should exert some pressure so that piston goes upside. So work done by the system, gas is doing some work to move piston in upward direction. Compression of the gas, someone should do some work on the piston to bring piston down, that is compression occurs. So during compression, initial volume is greater than final volume because compression volume decreases. Delta V is V2 minus V1 negative. W is P delta V, you will get. W is positive here. So work done on the system, positive we take according to sign pack, IUPAC sign convention. Work done on the system. See, remember here, work done on the system, it is work done is positive. Work done by the system, we take work done is negative. Heat. Energy transfer due to temperature difference. Energy transfer due to temperature difference. Sign convention is see here. If heat given to system, we take IUPAC sign convention, Q is positive. Heat given out from the system, then Q is negative. Units of work on heat same, calorie, joule or erg. 1 calorie is approximately 4.2 joules. 1 liter atmosphere 101.3 joules, 24.206 calorie or 101.3 into 10 power 7 erg. See units which is larger unit, liter atmosphere is more than calorie, joules, erg. See some fundamental questions here. Basic fundamental questions, important. Such questions you should be clear before entering into further important calculation based topics. See now, in thermodynamics, a process is called reversible when surroundings and system change into each other. There is no boundary between system and surrounding. The surroundings are always in equilibrium with the system. Yes, already we studied just now. In reversible process, here we specified system is in equilibrium at all stages. Equilibrium with what? Equilibrium with surrounding at all stages. So that's why it is correct. Out of boiling point, entropy, pH and EMF cell, intensive properties are. So EMF intensive property, pH value intensive property, boiling point also intensive property, entropy is extensive property. So here you will get 1, 3, 4. This one should be. So here it is, entropy is extensive property. They are asking about intensive property. Next, a cyclic process ABCD shown in PV diagram for an ideal gas. Which of the following diagram represent the same process? The question what we discussed above, same like here. You see first any one process, first observe it. A to B. What we can see here? A to B system. Here pressure is constant. A to B system, pressure is constant. So if pressure constant, what is observed? Volume directly proportional to temperature. Volume directly proportional to constant. Directly proportional to temperature. Now, here observe it. So at constant pressure, here volume increasing. At constant pressure, here volume in this direction, see AB, in this volume increasing, temperature should increase. You find first AB, here which is constant? Volume is constant. Volume is constant, temperature increasing, but volume should increase here. Volume is increasing in this case. It should not be. See here AB, here AB, A to B volume increasing, here B to A volume increasing. B to A volume increasing. No need to think here. So A to B here volume increasing. A to B here volume constant. A to B volume constant. Here, first of all, volume increases, temperature increases. Here volume increasing, so temperature should increase. So with increase in volume, temperature also increasing. AB, only see AB part. Everywhere AB position you see. So at constant pressure, AB process given, isobaric process. So volume directly proportional to temperature. This one should be correct answer, because here this particular part it is increasing, volume increasing, temperature also increasing, representing constant pressure. Okay. See, one should be very clear about these basic fundamental properties, whatever we studied, definitions or general simple formulas. Once we were clear with these terms, whatever we studied till now, upcoming questions, upcoming videos will be very easy. Okay. For more updates, follow the channel. Thank you. Thank you everyone.